A startup. Series A. The engineering team was competent. They built a RAG system, selected the most cited vector database across every implementation guide, every tutorial, every technical thread published in the preceding 2 years. Month 1, $180. Month 18, $11,200. Vector count increased 6 times. The bill increased 62 times. Same database, same vendor, no configuration changes. The variable was the billing model, and nobody read it before signing. That is what this audit covers. A vector database does one thing. Before the cost structure makes sense, the mechanism has to be clear. Your application holds text, documents, contracts, support tickets, product records. The requirement? Search that text by meaning, not by keyword. Retrieve everything related to billing disputes, regardless of whether any document contains that exact phrase. The process? Convert text into vectors. A vector is a numerical array between 384 and 3072 values that encodes the semantic content of a text passage as coordinates in mathematical space. Passages with equivalent meaning occupy proximate positions. Passages with unrelated meaning occupy distant positions. The vector database stores those coordinates and executes one operation at production speed. Given a query vector, return the nearest stored vectors. That is semantic search. That is the operational foundation of every RAG pipeline in production in 2026. Standard relational databases cannot perform this efficiently at scale. Vector search requires approximate nearest neighbor index structures, HNSW, IVF, that were not part of the relational database design contract. The technology is settled. The billing is where teams destroy their infrastructure budget. 4 categories of vector database solution exist. Engineering teams evaluate them on latency benchmarks and integration complexity. Billing architecture does not appear in most evaluations. Category 1. Managed proprietary. Pinecone. Fully managed, serverless. Billing is per operation. Every read unit, every write unit, every query execution. Category 2. Open source, self-hosted. Weaviate, Quadrant, Milvus. Deployed on owned infrastructure. The software carries no license cost. The billing is compute. Category 3. Postgres extension, pgvector. Vector search capability added to an existing Postgres instance. The extension is free. Billing is the instance. Category 4. Managed open source. Weaviate Cloud, Quadrant Cloud. Vendor-operated open source. Cost and operational control sit between categories 1 and 2. The financial variable that separates these categories is not pricing level. It is billing structure. Pinecone bills per operation. Costs scale with query volume. pgvector bills per instance. Costs are fixed regardless of query volume. At low volume, the delta is immaterial. At production volume, the delta is $26,496 over 3 years. The scenario: mid-size B2B SaaS, RAG system for document retrieval and support automation. 10 million vectors at 1,536 dimensions. The OpenAI text embedding 3 small default. 1 million queries per day. This is not an edge case. This is standard production scale in 2026. Pinecone billing, component by component. 10 million vectors at 1,536 dimensions occupy approximately 120 gigabytes of index storage. Storage is billed at $3.60 per gigabyte per month. Storage cost before the first query executes, $432 per month. Read units. 1 million queries per day at baseline consumes 1 read unit per query. Production RAG systems do not run baseline queries. Metadata filtering by document type, date range, tenant identifier, access tier consumes 5 to 10 read units per query, not 1. Production RAG systems filter. This is not an edge case. This is the operational baseline. At 3 read units per query, a conservative production estimate, monthly read consumption reaches 90 million units. At published rates, the read cost is $22.50. That figure is incomplete. At sustained concurrent load, Pinecone activates a capacity reservation charge. This fee is absent from the base pricing page. It is absent from the pricing calculator. It appears on the invoice. Capacity fee range at AI agent production load, $50 to $150 per month. Pinecone realistic monthly total, $680 to $1,100. Midpoint, $890. pgvector, identical workload. A WSRD SDB.M5.large, PostgreSQL, single availability zone, US East. $140 per month. 120 gigabyte storage at $0.115 per gigabyte, $14. pgvector extension, $0. No read unit, no write unit, no capacity fee. 1 million queries per day carries the same bill as 10,000. pgvector monthly total, $154. 3-year cost delta, $26,496. Identical data, identical queries, identical search output. That number does not appear on the architecture proposal. It accumulates on the invoice. The migration cost is the second invoice, 18 months post-deployment. Monthly cost has reached $3,000 as data volume grew. The decision to migrate to pgvector is made. Re-embedding the full dataset, $750 in API costs at current OpenAI embedding rates. Engineering time for pipeline construction, parity validation, parallel testing, and cutover management. 2 weeks at senior engineer rates, $9,600. Dual system overlap during transition, $1,500 to $3,000. Total migration cost, $12,000 to $15,000. Billed 18 months after the original decision. On top of the $26,496 differential already paid. This is not a penalty. It is the deferred liability of the initial architecture choice. The cost existed at day one. The invoice arrived late. The decision framework. 3 tiers. No ambiguity. Fewer than 1 million vectors. Fewer than 100,000 queries per day. pgvector. Pinecone at this scale charges a $50 monthly floor for capacity that generates no return. pgvector runs on infrastructure that already exists. Verdict. Pinecone is dead overhead at this scale. 1 million to 50 million vectors. Up to 1 million queries per day. Start with pgvector. A correctly sized instance with HNSW indexing handles this load. If P99 latency breaches the SLA threshold after index optimization, and the bottleneck is confirmed as index performance, not application architecture, then evaluate alternatives. Exhaust pgvector optimization before that evaluation. The cost differential justifies the engineering time. Verdict. pgvector is the correct default at this scale. Migration is an option, not a requirement. Above 50 million vectors, multi-tenant isolation requirements, or sub 10 milliseconds P99 latency SLA at sustained load. At this scale, dedicated vector database characteristics begin to produce legitimate financial justification. Sufficient query volume exists to negotiate custom commitment pricing. Engineering capacity exists to absorb operational overhead. One prerequisite before signing: audit metadata filtering distribution. If 80% of production queries include metadata filters, actual read unit consumption runs 5 to 8 times the raw query count. That calculation must be completed before any commitment contract is executed. Verdict. Dedicated vector databases become financially defensible at this scale. The contract still requires a line-by-line read before signature. The startup from the opening migrated to pgvector 14 months after launch. Migration cost, $14,000. Post-migration monthly bill, $890. The migration cost was recovered in 19 days. The $11,200 monthly bill was not an engineering failure. It was the result of selecting infrastructure without running the billing model comparison. That comparison requires one afternoon. The invoice runs for 3 years. All pricing figures reflect official vendor documentation as of May 2026. Cloud pricing terms update quarterly. Verify current rates before any infrastructure commitment. Subscribe to the Stack Anatomy. We'll see you in the next dissection.